Hello, my name is Mariusz Sabat, and together with my friend Brendan, we would like to show you the extensions to the SPIRE server and Helm charts for deployment of Red Hat OpenShift. All this work supports our project on Universal Trusted Workload Identity for Hybrid Cloud that is sponsored by IBM Research. The name of the service is Tornjak, and that's also name of the pretty cool dog breed. Today we will cover following topics. We developed a UI component for the SPIRE server, organized the deployment of all the components on Red Hat OpenShift platform, incorporated automatic registration of the workloads with identity policies. We developed a prototype of the management UI for driving multiple SPIRE servers with different trust domains. The benefits of such centralized tool include global visibility with single source of truth, a consolidated audit point for your organization. The management is centralized and allows enforcement of the SPIRE server authorization and policy management from one unified place. Additionally, it functions as an integration point with authorization frameworks for different workloads. If you'd like to skip to a specific section or demo, please check the timestamps in the video description. Each SPIRE server deployment will come with the additional web server and UI. By default, the server will be set up to only be accessed locally. The Tornjak backend will communicate through the socket. Configuration can be changed to allow no socket connection and use credentials that can be passed instead. The idea is that user can manage their SPIRE server deployment and lock down or expose the interface if needed, putting their own security controls around them. So the Tornjak becomes a proxy service between the user and the SPIRE server. So let's take a quick look at the Trusted Service Identity deployment that is using SPIRE service for managing workload identities. Let's start at the bottom. The solution is deployed on OpenShift, that is a new universal platform that works on any cloud. This can be IBM Cloud, Amazon, Azure, or even bare metal. Then we have a Kubernetes cluster where we can deploy Tornjak service with the SPIRE server. That's the box on the right. We can use the Tornjak namespace, and that's called project in OpenShift. Tornjak front-end UI is written in React. This is what user can access through the ingress endpoints. We currently support HTTP, TLS, and mutual TLS. There are also encryption keys and certificates for the secure connection and the security context constraints, SCC. These are the OpenShift permission controls. On the left, we have the Kubernetes cluster for hosting the actual workloads. Everything is running on OpenShift with the proper SCS. SPIRE agent is deployed as a daemon set. We also have a trust domains. They have to match between the SPIRE agent and the SPIRE server. There's also a workload registrar that is obtaining information about this cluster from Kubernetes APIs and is passing it to the SPIRE server through the TLS ingress access point. But the workload registrar needs to access the SPIRE server to push all the information. How can this be done? In order for the workload registrar to access SPIRE server, we need to provide identity. We can create a SPIFFE entry on the SPIRE server, define the parent, which in this case would be the agent sitting on the same worker node as the registrar, and using selectors defined the attributes of the workload registrar. Once this ID is created, it will be provided to the workload registrar, which can create entries in SPIRE server. Now a few words about the Helm deployment on the OpenShift platform. The Helm charts and the installation scripts are in our public GitHub repo under IBM Organization and TSI project. Under Utilities, we have several installation scripts, including two that are going to be used for this demo. First, we will deploy the Tornjak server that includes front-end UI, back-end Tornjak, SPIRE server, and everything else needed to deploy it on OpenShift. Then we will deploy the agent side. This includes the SPIRE agent daemon set on every worker node, workload registrar, and all the required permissions. Let's start with the first demo. During this demo, we will deploy Tornjak namespace. That would include the security context constraints for OpenShift, UI, backend, SPIRE server. This is all deployed as a stateful set, and various endpoints, ingress endpoints in HTTP, TLS, and mutual TLS for the given root CA. Then we will deploy the SPIRE namespace, also with the OpenShift permissions, this time with the SPIRE agent in form of a daemon set and the workload registrar. Because we don't know which node would be hosting the workload registrar, we have to define one entry for each agent that is in this environment. So here is a sample entry for the registrar. It takes the SPIFFE ID, for example, the workload registrar 1, the parent ID, that's the SPIFFE ID of the parent agent, and the selectors. The selectors include the service account, namespace, and the name of the container. Of course, we have to enable the administrative flag, which would allow this container to write SPIRE server. And at the end, we'll review all the UI components that show the list of agents, entries, and the server information. And now I will show you the deployment of the Trusted Service Identity with SPIRE on OpenShift. So I have an OpenShift account created in IBM Cloud. So I will copy the kubeconfig location into my console. And let's test if I have access to the cluster. Yes, so I have a cluster with 2 worker nodes. Okay, let's start the deployment. We are going to be using utility script that is driving the Helm chart deployment. This script requires the cluster name and the trust domain. So let's put the cluster name TSI ROX02, and we use trust domain TSI ROX02.com. So first the script would validate all the requirements. If we have JQ installed, OpenShift client and Helm, then it sets up the permissions for OpenShift, creates the certificates and private keys that would be used by TLS and MTLS. Okay, now is setting up the ingress access to the cluster, and as you can see, we have multiple access points. So there is an ingress for TLS, for mutual TLS, and simple HTTP access. Here is the list of the access points for all the services. Okay, let's verify SPIRE server was deployed. It is up and running. Excellent. Right now we need to copy the public access point to the SPIRE server, which is needed for configuration of the SPIRE agents. So now we can deploy the SPIRE agent on every worker node. We use again another script, this time called SPIRE, that creates entries in SPIRE namespace. This script requires the cluster name of the cluster, we use TSI RAX02, the SPIRE server endpoint, which we already have here, and trust domain. The trust domain must be the same as the server trust name. So we're going to use tsi-rox02.com. Once again, it validates all the required components, sets up the OpenShift permissions, and deploys all the components required by the agent. Let's validate. Yes, we have 2 agents deployed on every worker node and the workload registrar deployed on one of those nodes. Let's try to connect now to the SPIRE server. For the purpose of this demo, I will use TLS connection. Okay, so we are connected. You can see 2 agents and no entries. Here it's the server information. This is basically the SPIRE server configuration file. The entry list is empty because the registrar is running in the background, collecting information about the cluster, but doesn't have permissions to write into SPIRE server. We need to pass the identity to registrar and with the admin privileges so it can write to the server. Okay, so let's go back to the Helm deployment where the script outputs some useful information for creating the entries. We have a sample SPIFFE ID for the registrar, the parent ID, and the selectors. So let's copy the first agent because we don't know on which node the workload registrar was deployed. So we use first agent as a parent ID. Then we copy the proposed sample workload registrar as SPIFFE ID. We call it number 1. And let's get sample selectors. This means the service account has to be SPIRE Kubernetes registrar. The Kubernetes namespace has to be SPIRE. And the name of the container must be Kubernetes workload registrar. Of course, we can extend this with more selectors, but for the purpose of this demo, it's enough. Let's select the admin flag because the registrar would require admin privileges so it can create entries in the server. We create the entry. It was successfully created. Let's now create entry for the second node. So I'll copy the second agent as a parent ID. Just in case the registrar was deployed on the second node, I'll copy the SPIFFE ID and call it registrar 2 and the same set of selectors. Of course, admin flag required, create the entry. Now the workload registrar is active, it has permissions to track all the activities on the agent side and push them into SPIRE server. Now we can see 2 entries for the registrar. So let's create a sample container. In example SPIRE, my Ubuntu, and let's put this container into a test namespace. Okay, container is up and running. Let's see the entries for this deployment. And we can see multiple entries now listed. They were all registered through the registrar. So the first one here is the Ubuntu container. Then we have 2 agents, one for every worker node. You can see the IP addresses of the worker nodes. And here are the workload registrar IDs, number 1 and number 2. I also deployed here a second cluster, TSI RAX01, and Brendan will show the Tornjak Manager to manage both clusters. Okay, so that was the first demo, and here is the proposed architecture for our Tornjak management UI. So user is interacting directly with the Tornjak management UI, written also in React. The access to the portal will be controlled by some external identity and access management tool like IAM or LDAP. The Tornjak management backend is managing the API calls to the individual Tornjaks. All the connection information for individual Tornjaks are stored in a management metadata database. Okay, so going down to the individual Tornjak level, they also have their own UIs as you have seen on the previous demo. These individual Tornjak backends communicate via socket with the corresponding SPIRE servers, as it was shown earlier. On the right, we see the external component for managing the policy and authorization of admin workloads as one of the SPIRE security hardening features. This is already an issue open with the number 1975, and the login component for centralized audit. So moving on, here is the picture of the current prototype minimum viable product without any of the external tooling yet. So we've seen the picture of the trusted service identity. This is now how it looks like when we introduce the Tornjak management UI. By having this Tornjak management, we can now support multiple individual Tornjaks with the individual SPIRE servers. That also allows us to control multiple trust domains. So here is the layout for the demo. During the demo, we're going to have two clusters. One is on the ROX 1, the other ROX 2. User would be interacting with the Tornjak manager that talks directly to the Tornjak backends. We could experiment with HTTP and TLS connections. Tornjak backends would be communicating directly with their own SPIRE servers. So during this demo, we'll show you the global visibility, the basic authentication that is non-SPIRE native via mutual TLS, and additional API to show the configuration. So Brandon will show you now the second demo.
Now that we have seen the deployment of the identity components such as the SPIRE server and agents on the OpenShift clusters, as well as the developer and operator workflow of how to use these identities, let's take a look at the perspective of a CISO, or Chief Information Security Officer, someone that wants to manage and define the workload identities and policies across the organization. This is done through the Tornjak Manger. The Tornjak Manager solves the problem of having to manage identities across different platforms, allowing one to manage organization-wide workload identities and policies, as well as monitor and audit workload identity throughout the organization. How this works is through the Tornjak management interface that we see here, as well as corresponding Tornjak agents which sit beside the SPIRE servers. So let's go ahead and take a look at how we can do this. First thing that we want to do is to manage the servers in which the manager sees. So we do this by going into the Manage Servers tab. And over here we can see that we have already registered a server, which is the ROX 1 clusters that we showed in the demo earlier. Now we can see that we registered this. We have registered it to the MTLS endpoint. So what happens here is that the manager is talking to the agents sitting beside the SPIRE servers and is authenticating it through mutual TLS. So now that we have one server already registered, let's go ahead to register the second server. So we can say call this the ROX 2 cluster. And in this case, let's just create one with TLS. So we're going to go ahead and copy the domain of the server. We have the TLS one for ROX 2, we can see here. And we are going to click TLS enable and select the certificate file to validate. And we go ahead and register the server. We can see that it's registered successfully. And so the next thing we can do is then we want to look, for example, at the entries of these servers. So again, this provides global visibility on workload identity across the organization. So within the entries list, we can see we can make the selection of the ROX1 cluster. And this tells us a lot of information, right? It tells us what are the different identities that are listed here. But more importantly is if we look at, for example, one of these identities, we can see that this was the identity created for the workload registrar when we were installing it. And we can see that it belongs to a particular agent which specifies the node. And the interesting part over here is that someone like a CISO can take a look at these identities and see that the properties that it has, the attestations that are required in order to make this, to authenticate this identity. So in this case, each identity that you see here has a set of selectors. In this case, the selectors say that this particular identity requires the service account of the SPIRE Kubernetes registrar. It requires that it be in the SPIRE namespace, as well as have a certain container name. So the idea here is that someone like the CISO can go through and audit all the different workload identities that are being created, as well as the attestation requirements of them. So we scroll down here, we can see, for example, this was the identity that was created for the workload for the developer. So this is the ROX1 cluster. We can do the same thing with the ROX2 cluster. As you can see here, the entries have changed, and these are all the workload identities of the ROX2 cluster. Naturally, we can do the same with agents and so on, being able to see details of it. And for here, we can see that the agents have as well selectors with them that denote the node attestations required to authenticate those agents. So the idea here is now the CISO can use this to audit the workload identities, as well as what this platform will provide in the future is to be able to govern the policies around these identities, to be able to say what are the identities that can be created, and to be able to have central governance and the source of truth for them. In addition to that, we will be able to obtain audit log information about identity usage, so that the CISO as well as auditors are able to collect evidence to provide about the workload identity across the entire organization.
And here is the list of our GitHub repos and our contact information. Thank you for watching.